This is part 2 of our video on power rule. Hopefully you took the time to look at the original functions, look at their derivatives, and see if you could find any patterns. So I decided that I felt that j of x and n of x were the two that were incorrect. So for j of x, I had 2x cubed plus 1. And I noticed that for all of the other ones where it was just a number, so like 10, the derivative was 0. When I had 2x plus 1, right, there was no 1. When I had negative 5x plus 10, there was no 10. Anytime I had a number that didn't seem to have anything with it, like this negative 1 here, right, it just kind of disappeared when I took the derivative. So I don't think that plus 1 should be there. And then n of x, I noticed when I was looking at all the different examples that it appears that we're taking the exponent and multiplying it by the coefficient, right? And then we're taking 1 off of that exponent. So 5x squared, my derivative was 2 times 5, which is 10. And then x to the, if I take off 1, x to the 1. And then my derivative, well, we'll talk about that one. When I had x cubed, right, I did 3 times the invisible coefficient of 1. And then I took 1 off the exponent to get x squared. Or here, when I did 10x to the 6, I did 6 times 10, which is 60, and then I took 1 off the exponent, which was 5. But with the 3x cubed, right, I should have done 3 times 3 to get 9, and then take 1 off the exponent to get x squared. So I think the problem here is that 3. I think that that should really be a 9. So power rule is a shortcut for finding derivatives of polynomial functions. And they need to be polynomial functions that are in standard form, so they're not factored, they're not fractions, right? They're just multiplied out polynomials. So I hope that you noticed that when we're taking the derivative, we take the exponent, we multiply it by the coefficient. So here 5 times 2 is 10, and then we're taking 1 off of our exponent. So I'm going to try that with this one here. I have f of x equals x squared plus 2. So if I try to do the derivative of this to get f prime of x, I'm going to do 2 times the invisible coefficient of 1, which is 2, and then x to the power of, I'm going to take that 2 and I'm going to take 1 off the exponent to get 2x to the power of 1, or I could just write 2x. Now this 2 does not have an x with it. So technically, if I wrote one in, it would be x to the power of 0. So 0 times 2 is 0, and then times x to the negative 1. But 0 times anything is 0. So the derivative of just 2 is going to be a 0. So power rule, we're going to write down on the next page, is just a shortcut for calculating our derivatives. We take the exponent, right? We multiply it by the coefficient, and then we take 1 off of the exponent. And we do that for every term in that polynomial. Okay, so as our rule here, it says if we have f of x, which is a times x to the power of n, the derivative of f of x, we would do n times a, so we're doing n times a, and then we're going to take 1 off of the exponent, so times x to the power of n minus 1. That's what power rule is. So we're going to try a couple of questions using our power rule. So it says use power rule to find the derivative of each of the following functions. So up first we have f of x, which is x squared plus 3x minus 5. So if I want the derivative, that's going to be f prime of x. And then all I'm going to do is use my power rule for every single term. So for the x squared, I would do 2 times the coefficient, which is a secret 1. So 2 times 1 is 2. And then I would take the exponent down 1, so that would be x to the power of 1. On my next one, that 3x has a secret exponent of 1. So 3 times 1 is 3. So this is plus 3. And then if I take a 1 off of my exponent, I actually get x to the power of 0. And then my last one, that -5, it has x to the 0. It doesn't have an x term, so there would be no x's there. So if I do this one, 0 times -5 is 0. I can either write +0 or -0. And then that would be times x to the power of, if I take one off, -1. Now if I go through and I simplify, I don't really need to write that power of 1. I could just write 2x. 3x to the power of 0. Anything to the power of 0 is 1. And then 3 times 1 is just 3. So that's going to be 2x plus 3. And then 0 times anything is 0. So I don't need to write that. So my derivative, f prime of x, is 2x plus 3. That's the equation of the slope, right, or rate of change at any point on that function. And it's a lot faster than doing the formula using the limit. Okay, as you get going and you get better at it, you start to learn that the derivative of a number is 0, right? Or that when I take the derivative with an x, we're not going to have an x in our answer. And you'll get faster at doing them, but because this is the lesson, I'm going to do all the steps. So for b, we have y equals 4 times x to the power of 3 minus 2 times x plus 10. So to find the derivative, this one is written as y, so I can do dy by dx, which we said is really like a lowercase delta, so that's delta y over delta x, which is slope. Okay, we're going to do 3 times 4, so that's 12, and then x to the power of 3 take away 1 is 2. All right, this one has a secret exponent of 0. So -2, nope, I take that back. That has a secret exponent of 1. Sorry about that. So -2 times 1 is -2. And then x to the 1 take away 1 is 0. And then that 10 is secretly a 10x to the 0. So 0 times 10 is 0. And then x to the -1. Like I said, the more you do, you start to just recognize that the derivative of a constant is 0, so that you don't need to show the extra steps. So dy by dx is 12x squared. The x to the power of 0 is just 1, so 2 times 1 is 2, so that's -2, and then 0 times anything is 0. So our derivative is 12x squared, take away 2. Okay, the next couple are going to get a little more difficult just because of their exponents and their coefficients. So if I take a look at C, it says g of x is 2/3 x to the power of 6 minus x to the power of 4 over 4. So if I take a look at this, I'm going to try using my power rule. So I'm going to say g prime of x, that's how we do the derivative with function notation. I'm going to multiply my exponent times 2/3, right? So that exponent is secretly 6 over 1. So when I multiply, I do top times top, bottom times bottom. So 2 times 6 is 12, and 3 times 1 is 3. And then that would be x to the power of, we take 1 off, 5. Now here, x to the 4 over 4. I could rewrite that as 1 over 4 x to the 4. So anytime you have a fraction, you can just move it in front instead of having it be over the denominator. So if I go to take the derivative of that, I'm going to get negative 1/4 times 4. That 4 is secretly over 1. So I do top times top, so 4 times 1 is 4. Bottom times bottom, 4 times 1 is 4. And then x to the power of 4, take away 1 is 3. All right, we're going to just divide anything that we can here. 12 divided by 3 is 4, x to the 5. 4 divided by 4 is 1, and then x to the 3. You don't have to write the 1, you could just write x to the power of 3. And that's my derivative. We will eventually take a look at factoring our answers, but for right now, I'm happy just to leave it as a polynomial. All right, next one, I have y equals 2 over a to the power of 3. Now this one is different because the variable is in the denominator, which technically makes this a rational exponent. So what I would like to do is write it as a power instead of a fraction. So my first step before I even do the derivative is to rewrite the original function so that this is a power instead of being a fraction. So a negative exponent makes a fraction, right? So 2 over a to the power of 3 would be the same as 2a to the power of negative 3. And then from here, I can take the derivative using my power rule. So dy by dx, since it's written as a y, is going to be negative 3 times 2, that's negative 6. And then a to the power of, I'm going to take 1 away from negative 3, which is negative 4. Now, if the original one was written with negative exponents, I would leave my derivative with negative exponents. But if my original was written as a fraction, I am going to try to write my final answer in the same format, so as a fraction. So that negative exponent is only on the a. So it's going to leave the 6 on the top, the negative 6 on the top, and our a to the negative 4 is going to go down into the denominator because a negative exponent makes a fraction. So our derivative is negative 6 divided by a to the 4. Okay, I think I'm going to save the next two for the next part of the video.